afternoon all. My name is Ahmed Othman. I'm leading the Advanced Process Solutions Division at Saudi Aramco. And it's really a great pleasure for me to be here to participate at the RC Industry Forum. In my presentation today, I'll be sharing with you some of our ongoing efforts in introducing advanced digital solutions that helped us in optimizing our oil and gas network with the objective of enhancing and maintaining Saudi Aramco leadership positions in the area of sustainability and energy efficiency. So in my presentation today, I'll start by giving a high-level overview on Aramco's oil and gas network. Then I'll start introducing the concept of enterprise-wide optimization. After that, I'll be talking about specific examples of some of the major solutions that we have successfully deployed and how they have contributed positively in meeting our sustainability goals. And I'll end the presentation by having future perspectives on the future work that we plan to do in this domain. So Aramco operates one of the largest integrated oil and gas network. Taking a quick look at the key figures, we operate more than 50 gas oil separation plants, 3 major crude stabilization hubs, 10 gas processing facilities, and 3 NGL fractionation facilities. And also we have a total of 14 refineries between locally or internationally available, both whether wholly owned or partially owned by Aramco. These facilities bring basically massive processing capacity. Key figures to highlight here, we have the maximum sustainable capacity of crude production is around 12 million barrels per day. 12.5 billion standard cubic feet of gas per day is the amount of gas that we're able to process across our entire gas network. And we also have a total refining capacity of 4 million barrels per day. At Aramco, we also have tremendous operational flexibilities that are available at the swing lines between the different gas clusters, the transfer line between the gas and NGL facilities that enable us to shift the loads between these facilities, and also thousands of kilometers of pipelines, tanker, and hauling operations. Such operation flexibilities basically provide perfect environment for us to capitalize on the digital transformation advancement, as well as the advancement in operations research to help in optimally operating the entire network while meeting our corporate objectives in sustainability and energy efficiency. So part of our digital transformation, we have introduced several digital solutions with the objective of meeting what we call an enterprise-wide optimization. The main objectives are basically to help in further advancing Aramco's sustainability, reliability, as well as competitiveness by integrating and optimizing our supply, manufacturing, and distribution activities at multiple hierarchical levels. The key benefits of such approach is basically ability to systematically evaluate optimum decarbonization routes while limiting emissions for operating assets, optimizing our capital investments for green and brownfield investments or projects while maximizing the profitability of our operating assets. Planning under uncertain conditions for new projects is also an area that enable us to integrate our company-wide operations in a more optimal manner. So at the enterprise-wide optimization, we look at it in a hierarchical manner such that we introduce tools that would help us in making decisions at the strategic, tactical, and operational levels. So the strategic activities will be basically focusing on the big picture and the long-term decisions that are made for in the range of 5 to 25 years. This will be achieved by optimizing the policies and investments portfolios to support our corporate decision-making activities. The tactical activities basically will be the medium-term focus on 3 months to 3 years, and those will help optimize the business plan and short-range operating plans while ensuring that the business units will be in alignment with our long-term and strategic plan. The operational activities will be focused on the day-to-day operations, optimization in real-time or near real-time manner. This will help optimize the process and energy efficiency while basically ensuring alignment with our tactical targets. So getting into a bit more details, this slide basically shows in a high level some of our ongoing efforts in introducing various digital solutions and technologies. And as you can see, we are tackling these solutions across the hydrocarbon value chain at multiple decision-making levels. So starting at the bottom, the advanced process control applications provide the foundation for stabilizing the process units and enabling local unit optimization. Real-time optimization is the next operation layer, where we basically started implementing this in some of our refineries, and we have a plan to expand the deployment to the remaining refineries as well as the NGL fractionation facilities. And I'll be talking more about that solution in my slides. Both the oil and gas network lend themselves to a perfect or interesting optimization problem, where I'll be also sharing with you some of the solutions that we have recently introduced and how they have contributed in better managing our entire oil and gas network. Other scheduling, planning, distribution applications are instances of optimization solutions as well, and these are heavily utilized at both the tactical and operational level. Our future plan is to extend this effort and put more focus on introducing similar tools that will help us in making the long-term and strategic planning, especially in the area of sustainability and energy transition. So starting with the first example, and it's the application of using these tools to optimize our oil network. The first solution is the Oil Hub, which is a solution that advises on the optimal feedstock routing and equipment operating parameters for the entire Aramco's GASPS network. During normal operation, the tool can be basically used to assess which plants to load in order to optimally meet the production targets given the varied or the different configuration of these different facilities. On the other hand, during emergencies or plant turnarounds preparations, the solution can be used to advise on how to best redistribute the feed so that we meet the oil production demand and while taking into account the process and network limitations. The key benefits of that solution include minimizing the energy consumption and greenhouse gases emissions, and we have demonstrated ability to reduce the emissions and energy consumption by around 23%. Minimizing also demulsifiers or chemicals consumption at the GASPs is also another area that we have demonstrated how this tool can be benefit for us. We've experienced a reduction of around 12% of the chemicals consumption at the GASPs facilities. Also maximizing the gas and NGL production that is associated with the oil production to support the kingdom's power and petrochemical increasing demand while minimizing the capital investment that we need to meet such increasing demand. The solution basically combines both well and GASPs models in the same flow sheet. A typical model can consist of up to 700 wells along with 19 different GASPs in the same network. This allows solving the production problem holistically and in an integrated manner. The optimization problem involves 1,600 variables and over 500,000 equations to solve this planning optimization problem. The objective functions covers basically either maximizing the production or minimizing the operating cost. For example, our engineers can utilize the tool to define what would be the maximum gas and NGL production for a given crude oil production rate. After that, the engineers can run a subsequent run utilizing the tool where they fix the crude oil production as well as the gas and NGL and let the tool advises on the most optimal way to operate the entire network while minimizing the energy and emissions and meeting the targeted crude oil and gas NGL production rates. So taking a look at a specific use case which involved minimizing the energy consumption, the objective was basically to minimize the energy consumption for a network of GASPs of 11 GASPs at various production levels. The solution outcomes are best routing scenarios, individual GASPs throughput, and equipment utilization. This resulted in defining different production plan with a power consumption reduction in the range between 3% and up to 48%, depending on what crude oil production level for that operating scenario. Specifically, the solution recommended shutting down around 12 rotating equipment between gas compression or compressors as well as water injection pumps. Connecting the dots further, we looked at how individual wells can be optimized. Typical oil field consists of around hundreds of oil wells that are spread across an area of around 100 square kilometers. The oil wells individually produce a few thousand barrels per day, and modern oil fields are digitalized, hence enabling us to manipulate key or critical process parameters such as the electrical submersible pump speed as well as the chuck valve opening. And that creates multiple optimization opportunities at both the well level as well as the entire oil field level. So implementation of the advanced process control at our oil field helped in optimizing the energy consumption of individual ESPs in the range of 10% to 20%. Clearly, this energy consumption reduction would reduce the amount of emissions from that oil field, besides also improving the lifetime of the ESPs. The next challenge for us was to expand or scale up the deployment across hundreds of oil wells that are spread across an area of 200 by 25 square kilometer. So what we have applied is basically we used machine learning and specifically clustering techniques so that we identify similarly behaving wells. This was an example of unsupervised machine learning. And by doing this, we were able to find the representative wells and reuse the models from these wells. And that basically resulted in significantly reducing the amount of well testing that is needed, as well as significantly reduce the amount of engineering work, effort, which resulted in faster scale-up and implementation across the entire oil field. Next, we move to the example of optimizing our gas network. The solution here is the Master Gas System Optimization Solution, which is a real-time web-based platform to optimize the operation of the entire gas network. It combines both first principle and machine learning generated surrogate models and single flow sheet. So the surrogate models are basically simplified representation of the more rigorous process simulation models of the entire network. They are generated by iteratively and adaptively sampling the rigorous models and setting up the model with sufficient accuracy and high robustness so that we end up with a tool that's giving us very close output to the reality. The models start by collecting and treating the plant data. This is followed by performing a network-wide simulation every hour to assess the current performance of our gas operations. It then performs a network-wide optimization and it advises on the recommended changes to achieve the optimal operations. This includes changing the feedstock and plants loading, as well as individual plants' critical operating parameters. The profitability objective function is maximized, taking into account the GHG emissions, which is represented in the objective function as a penalty, so the solution will always keep minimizing the amount of emissions out of the network. The main benefits of the solutions are meeting the local sales demand in an optimal manner, while maximizing the NGL production and minimizing the energy consumption and GHG emissions. One of the use cases that we can highlight today is how the tool was used to minimize the SO2 emissions across our entire gas network. In this scenario, we have been given a fixed demand for sales gas with the objective to optimize the gas network in terms of profitability. The solution receives updated actual sulfur recovery efficiency generated from around 45 different sulfur recovery units and the 10 gas facilities that we have across the entire network. A massive or large mixed integer nonlinear programming is sold to maximize the network profitability while taking into account the penalty that is assigned to the SO2 emission. The resulted or the outcome of the solution is basically the optimal redistribution of the gas loading across our gas facilities, where we capitalize on the more efficient sulfur recovery unit. And in that case, we have demonstrated a reduction of SO2 emissions across the entire network by about 8%. The last example is that I want to share with you is basically an example of site or plant level optimization. And in this case, it's going to be a refinery-wide optimization. The challenge is to close the gap between the plan and actual for a refinery that is providing transportation fuel at one of our western region in Saudi Arabia. The solution is in this case, is a refinery-wide optimization applications that is based on rigorous models to provide real-time optimal operating targets for key process parameters. The main benefits are continuous maximization of the refinery's most valuable products while meeting the product specs and the process constraints. The payback period, it's worth mentioning that the payback period that we have seen out of this solution is around 6 months, which is basically typical for such type of application. So the RTO solution runs every hour in a closed loop, starting with the steady state detection, followed by the data reconciliation, and then the optimization. The targets that are generated by the RTO are written back to the APC, which ensures that these critical parameters are reached while handling the process interactions. The current pricing, constraint information, as well as the lab results are also fed to the optimization solution. The RTO, as you can see, pretty much cover all the major units in the refinery, which includes the atmospheric crude column, the diesel hydrotreater, isomerization, the CCR, as well as the splitter and the gasoline blending. So this was the last example. I hope this gave a high-level overview of our efforts in introducing such advanced tools and technologies, where we have experienced really improvements in achieving our sustainability targets. As mentioned earlier, our focus in the next few years is basically to extend this effort and focus on the strategic planning tools. The key focus will be basically to design for sustainability, energy transition, as well as decarbonization. We also plan to extend the deployment of the RTOs and process digital twins across our refineries. And generally speaking, we'll be continuing the efforts in leveraging the 4IR and digital transformation technologies so that we help our company to achieve its ambitious sustainability and energy efficiency targets. With this, I come to the conclusion for my presentation, and thank you for your attendance and listening.